Happy April Fool's Day. I'm not here with Martin, not at all. Oh, wait a minute, April Fool, serious? Don't look so silly. All right, get out of here.
Boys of the cohorts, we hope you like our show.
I do. Okay, so we're doing the module 12 on your own. This is on your own number 1. Page are we on, Smarty?
It's 7,421. Oh, it's actually 394.
You got me. Okay, on your own 12.1. So here we're working. What's the title of this module?
The gas phase.
So we're working with gas laws, and in this section, we're given actually 3 different gas laws, right? First is Boyle's law, has to do with pressure and volume, and it says that they are constant, right? There's a constant between them. And what is the other fellow's law?
It's
Charles' law. And you put them together, and Charles' law has to do with volume and temperature. Yeah. We put them together, and we get the combined gas law, okay, which is P1 V1
times V1 over T1 equals P2 times V2 over T2.
Right. So those are the things that we're going to need to know for these on your own. So please read 12.1.
A gas is stored in a metal cylinder with a volume that cannot change.
Okay.
If the gas is packed into the cylinder at a temperature of 0.00 degrees Celsius and under a pressure of 3,415 kilopascals. 3,415 kilopascals. What will the pressure inside the cylinder be? That's kPa. Yeah. What will the pressure inside the cylinder be when it is stored at room temperature, 25.0 degrees Celsius?
Okay, so I wrote down a number of facts as you were talking. First one is that the volume doesn't change, right? So V1 is going to equal V2. The second is the first temperature was 0.00. Did I get the right degree of?
Yeah.
Good. Degrees Celsius. And the next temperature will be 25.0 degrees Celsius. The pressure 1 is this value, and we need to calculate pressure 2. Is that correct?
No. First, before we do the algebra, we need to convert our units into Kelvin degrees.
Excuse me, we haven't done anything yet. I'm just saying we need to find this. Is that correct?
Yes.
Okay. So, yes, as Martin says, one of the important things that we need to remember is about Kelvin. What is the important thing that you need to know? That these laws
are always to be used with degrees Kelvin.
Mm-hmm. Okay. So you can use these rules as long as you have temperature in degrees Kelvin. Where do you find this important piece of information, Martin? On page 392. And it's in bold. Why?
So that we can see it easily.
That's correct. Because you have to memorize it. It's essential. It must be remembered. It must be remembered. Okay? So what else has to be memorized from this module?
Conversion units for pressure.
Yes, the equations.
Torrs, which is
the equations crazy. Throughout the module.
Atmospheres.
Yes, and you have to know the relationship of atmosphere to torrs and millimeters of mercury to atmospheres.
Also, which can be abbreviated as MERS.
Okay, so let's make sure we know all those things. All right, so the first thing we have to do, as Martin said, is to convert to Kelvin. How should we convert to Kelvin? What is, I believe you, what is the way to convert into Kelvin? When did we learn that?
273.15.
Yeah, I think we learned that in like one of the first modules when we were doing measurements and units.
I wish they bother restating it in this one.
Well, one thing you can always do is use the index. Let's just briefly do that and see if the index.
All the conversions back here, right? Okay, it looks like they don't have all the conversions back here.
But let's see where they have degrees. Let's see.
273.15, right? It's not so bad.
I'm gonna look on page 41 and 45. That's where Celsius is. Okay, so on page 46, we had equation 2.2, which told us that to find Kelvin, it's 273.15, right? Plus degrees C, right?
Yes.
So what's the first temperature then in Kelvin?
Well, that's 273.15.
It is, and because we are given our T1 in hundredths of a degree, we can retain that precision for Kelvin. And so we're going to say it's 273.15 K. We don't use the degree symbol with the Kelvin. Why? I can't tell you. How about for temperature 2? Temperature 2 is going to be 273.15 plus 25.0. What is the amount of precision in this degree? Martin, I'm asking you to look here. What is the amount of precision? Tenths. That means that my answer can only be in tenths.
So that's 298.2 Kelvin.
Yes. So we're going to, it's 1.5, so we're going to change it to 2. So temperature 2 is going to be equal to 298.2 Kelvin. Okay.
Sweet.
How about the pressure? Do we need to do anything with that? Okay. So.
Wait, should we convert it back to pascals?
I don't know that it matters. We'll just get an answer in terms of kilopascals.
All right.
So what is the equation that we need to use?
It's P times V over T equals P times V over T. We can cancel the V's and that makes sense.
That's right. So it's just going to be P.
P2.
Our initial would be looking like this. But since V1 and V2 are the same, we're just going to eliminate them in our equation. So we're going to have this. P1 is to T1 as P2 is to T2. So 3.
Shouldn't we solve for P2 before we put in the numbers?
Well, what's that going to be?
That's going to be P2 equals
right?
Yeah. So
okay, so I'm going to just multiply here. What's
P1.
that? T2 298.2 Kelvin, right? These units will cancel and we'll end up with something in kilopascals. So remember this? Let's say you're on the calculator. I'm doing the calculator today. 298.2 times 3415 equals, it's over a million, divided by 273.15 equals. So I have 1, 2, 3, 4, 1, 2, 3, 4, 5. I want to have 4 significant digits in my answer. 3, 7, 2, 8. Does that look right to you? Did the math correctly?
Yeah. It's a lot of kilopascals.
Okay, and that's it for number 12.1.
That's a lot of damn